morning, everyone. So today we're going to be looking at the nesting utility that's a part of your PDMC collection, or as an extension of the Inventor Professional software. So we'll just jump right into it. You can ask me any questions you have at the end, or just send in one through the chat box. So basically, in some form or shape, we've been using Inventor or aware of what Inventor as a tool does for us. 3D modeling software, just like SolidWorks, but definitely much better. So the nesting utility is a part of the product design and manufacturing collection from Autodesk. So basically, it's for customer products that are usually sheet metal parts that needed to be flattened and cut. So I suppose the goal or the idea of using nesting utilities as a tool is to optimize the material sheet for usage and reduce the wastage as much as possible. The other goal is also to create, I suppose, a nest and pass it on to HSM tools for manufacturing. Again, a part of the PDMC collection that is an extension really in the whole product design and manufacturing side of things. So what we're going to be looking at today is I'm going to be quickly running you through about how Autodesk really introduced the nesting utility in the 2019 PDMC collection, and it's been a big hit ever since. So it's obviously part of the 2020 collection as well. It's integrated with Inventor in the first place, so you wouldn't have to jump out, I suppose, off the Inventor software and open up a new one just to get your nesting done right, I suppose. So just quickly looking at the cutting processes, the cutting process that goes in from the designer to the shop floor. I suppose you have a basic assembly design, you have folded parts, you have sheet metal parts, and the designer, I suppose, is limited to the design and suppose unfolding of the parts really. So the manufacturing engineer is really the one who would be using the nesting tool, or even the design engineer as such. But the idea of using nesting as a tool for your manufacturing process is the ability to run different scenarios using your material sheets and your different packages that you can define. So this actually defines an integrated workflow from Inventor to nesting and to HSM, completing your whole, I suppose, your whole workflow really from design to manufacturing. So the nesting shapes are defined using the TrueNest technology. That is another high-end software that Autodesk provides for nesting utilities. The ability to group the thickness of sheets and spit out multiple sheets if need be is one of the added features of the nesting utility tool. You can leverage the DXFs from your generated from your nesting tool, and then bring them into HSM and generate your G codes. For your manufacturing. So basically, in front of you is a list that shows you the differentiation between, I suppose, the nesting utility tool and the TrueNest software. So the TrueNest software, I suppose, would be a highly integrated package, specifically concentrating on the nesting side of things. So nesting primarily works with TrueNest technology, and it's basically a part of your Inventor package. It gives you the ability to bring in different file formats, convert to sheet metal, and flatten them. So you could bring in any of your step files, your Pro-E files from your external vendor or whoever, and you can bring them into Inventor, create an assembly, save it as an assembly, and then use the nesting tool to create use the nesting tool to create flat patterns and optimize your sheets. I suppose with TrueNest, you have the ability to edit your nesting to a much more wider scale. It also comes as part, it's fully integrated with your product design manufacturing software and your Vault completely. I suppose the major difference at this minute, I would say people who would like to use people who have access to punch presses, ply cutting, and automatic cutting optimization tools, that is really where TrueNest, does its job. But if you're looking for a basic nesting tool, I suppose nesting utility would be the way to go, especially because it's part of your Inventor package completely. So the TrueNest software is really for people looking to use punches, your saws, high volume stampings, and all of those really. I'm going to straight jump into the workflow from your design to your ERP generation. So at the design stage, I suppose you could be using, as part of the Autodesk package, you would be using Inventor or Fusion. And for your nesting tools, you wouldn't have to jump out to a third-party software really, or to your machine vendors. So it's basically to optimize your workflow to the maximum and keep, I suppose, as far as possible. I suppose that's the idea, to optimize your workflow from going via Inventor as a design tool to Inventor using the nesting tool, and then optimizing using Inventor CAM, and to make the whole process much more faster and easier for the end user. So the Inventor nesting package really it gives you the ability to integrate your sheet metal parts and your assembly tools. You can read in the XFs from external sources, bring them in as long as they're closed loops. You can actually use them in your Inventor nesting tool as well. You can have multiple sheets of the same dimensions or multiple sheets of varying dimensions inside the same single nest, so you wouldn't have to repeat the process over and over again. It also gives you the associativity between your 3D model and your generated nests, basically. So what that implies is, if you had any last moment, say, design changes, you wouldn't have to create an entirely new nest. You could just go in and the nest would automatically be updated. Giving you the ability and the time saving, really, I suppose, behind going back and going back and forth and trying to optimize your workflow. You also have the ability at the end to export the nest as a DXF or a 3D model for visualization purposes as well. So if you had an assembly, you could use simple iLogic, and you could create individual DXFs of parts as well. So it's pretty much a very handy tool to have if you're looking to work with, if you're looking to optimize your nesting environment. So I suppose after creating the DXF in the nesting environment, you'd move on to the toolpaths and the code generation for your HSM and CAM workflows. At the end of it, at the end of the process of creating a nest and optimizing it, it'll also automatically generate nest reports for you, so that I suppose you can optimize the process much more conveniently and much more easily in a cost-saving measure, basically. So the nesting format comes off as a .inest, and if you have access to the nesting tool in your PDMC collection already, you should be able to download and trial it, run it as a trial or even as a full license. So it would basically come off as your standard IPTs or your standard IAM creations in the format of an inest. So you could have multiple files that would be step files or CATIA files or something like that you could actually bring into the assembly environment, and as long as it has one supported IPT, you can convert the whole assembly into a nest. Again, DXF files, you're easily able to import them and bring them and use them as long as they're closed shapes. So I suppose the idea here is to run you through quickly of how the Inventor nesting tools really works. So the nesting workflow is basically updating your material library in the nesting environment, creating the packaging according to what material sheets or sizes you have, importing your CAD files, translating them into flat patterns that can be used for your nesting, editing the nesting properties to, I suppose, your maximum optimization, creating a nesting study, and then viewing reports and exporting DXFs to say your CAM or your CAM tools or your HSM tools. So the setup for material and packaging window would let you have the ability to define different materials for a single study. So you could have default materials. If you have similar kind of sizes and sheets coming in, you could have all of those defined in here, customize them for yourself, and you could set up your nesting abilities to the maximum, I suppose. You can add different materials that may be part of your assembly, maybe not. You can use them as defaults, or you can actually create them on the go. So basically, the idea of creating, I suppose, the material library for yourself in a nesting environment would be to define those sheets, to let the nesting tool define those sheets individually. So you could have different materials, same thickness, so they would all come onto the one single sheet. That's how smart the software really is. So the idea after defining your basic properties would be to create a nest, importing and translating your CAD data. So you would go on and add your assembly files in here straight from your model browser window. So you would be able to see an option where you would be seeing multiple number of sheets according to their sizes and shapes. I suppose the best way that nesting initially thinks would be the best for you. It generates it calculates the nest to the optimum percentage, and you can see on the left hand side under packaging there's you have different sorts of options where it's been defined by the end user as steel, aluminum, and carbon fiber. So nesting would pick up that data and try to integrate it with what you're looking for and give you the best possible idea that it could come up with. If you're not happy enough with your nest calculations that come up from nesting, you have the option to go on and edit it. You can define the shapes, you can define orientation, flip it, rotate it, increase the number of, I suppose, the number of pieces coming out from the same sheet, especially if you have a load of material waste being generated. So it's basically giving you an automatic calculation at the start, and then it gives you the ability to edit a nest or customize a nest according to your liking, and basically giving you the maximum it can. So after all of that has been done, you have toolpath generation using CAM. You can export the DXF file after optimizing your nest, and then just straight away use it in HSM or Inventor CAM as such. It basically gives you the ability to look where you could possibly improve, or possibly where you might be going wrong. Basically, to improve your workflow is what it is. So I suppose the end-to-end solution going from 3D to nesting and to HSM is right inside Inventor. Now we're here in an Inventor 2020 environment. We're going to be looking at a small model on how the nesting utility tool would work. So basically, you can just right-click on your assembly environment and then just go straight into the nesting environment. So what it's doing here is basically it's importing the tool and it's defining the materials that it has. You can create a new study and it will optimize the sheet for you. You can see we have 3 different material sheets here, but they don't look highly optimized yet. So we're just going to jump into the properties and we're going to manually increase the quantity of the smaller number of parts here. So you can see that it has been updated, but now we have 2 different sheets and the efficiency of the overall nesting is pretty low. So you can define the gaps between your separate parts, and then you can optimize it, recalculate it, and it'll give you an improved nesting efficiency really. So you can see straight away, instead of having to do it on 2 sheets, you have it done on 1 sheet there. So you have the ability to create a 3D model out of this that can be brought into HSM or CAM when you're trying to define your tooling paths. Now here we're going to be defining a simple tooling path for cutting, and we're going to define a stock point using the CAM environment of Inventor. Using the cutting tool, we're going to go on and create a profile for laser cutting. So selecting all of the parts that need to be cut from the sheet, it'll define a tool path for you, and it will let you visualize the number of steps and the time it would take, where you could even optimize your manufacturing process really. So the idea is to keep you inside the Inventor environment and give you a one-stop shop for absolutely everything from design to optimization of your tool, optimization of your nest, and then moving on to manufacturing. So I'd say in summary really, the ability to integrate nest tools with Inventor sheet metal parts, the ability to optimize material usage and production capabilities, importing and exporting DXFs. It's useful for spots where you're looking to work with laser cutting tools, water jets, or plasma cutters, and even CNC routers in there. So the idea of getting you to work in the Inventor environment, I suppose, is the added option of the pack and go assembly environment. So what it does for you is, the pack and go option is basically you can send out your assembly from start to finish, including your nesting files, to somebody else, and they would be able to view the assembly and the files and the nesting files on their own without any hassle. So I suppose it's a crucial part of the workflow going from design to manufacturing, and it basically bridges the gap that you would usually have, and it'll help you cost optimize really. So it's exclusively there for product design and manufacturing collection subscribers, and that's what I suppose Inventor nesting is all about. Thanks for joining me today. If you guys have any questions, you can go ahead and ask me now, or you can send in a question or two to support@procad.ie, or just give us a shout at any of our blogs or web pages. Are there any questions, guys? Okay, I suppose that's really it. So thanks for joining me, guys, this morning. Thanks for joining me. Thanks, guys.